All right, hello everyone. Welcome back to Shaded Regions. And in this video, we're going to be talking about shaded regions and how to find the area of them. Basically, what we're doing with shaded regions is very similar to the composite area. So we're going to be finding area of multiple figures. So for this one, we're going to find the area of the shaded figure first. The shaded figure is going to be done first. After we find the area of the shaded figure, then we're going to subtract, we're going to take away the area of the non-shaded regions. So we find that the shaded area first, subtract everything that is not shaded. So that's all that we're doing for shaded regions. Let's go ahead and take a look at a few examples. We'll start up here with number 6. Number 6 is pretty straightforward. It's just a square. And then what we're doing after we find the square is we're going to take away the circle. So we have a square minus the circle. Okay. For the square, all we're doing is we're just using this 25. We have 25 times 25. Times 25. The square has an area of 625. And that is in feet, 625 feet squared. For the circle, this 25 still goes the distance, right? But we only want half of that distance because 25 is the diameter. So our radius is going to be half of 25, which is 12.5 feet. So that's going to be half of 25. So for the circle, we have a full circle this time. It's not a half circle. So we're doing pi r squared. We're going to keep the whole thing together. So I have 12.5 squared pi times 12.5 squared. That's going to be 156.25 times pi. And when I multiply those together, that gives me 490.87. Again, it is in feet squared. So now, just like we did or said we were going to do up here, we're going to take the area of the square and subtract out the circle. So we have 625, and we're going to take away 490.87. When we do that, 625 minus 490.87, we get 134.13. Again, it is in feet squared. All right, that's pretty much the gist for all of these. Just finding the area of the shaded region first. It's typically going to be the larger shape, and then we're subtracting away everything that is not that. So what we'll do next, since we haven't worked with many trapezoids in the last few videos, we'll do number 9. So the trapezoid is the large shape or the shaded shape, and we're going to take away the semicircle. So we have the trapezoid minus the semicircle. So we'll do the trapezoid in red. For the trapezoid, we have our height times base 1 plus base 2, all divided by 2. And fortunately for us, we have both bases, but we don't have the height. So we're going to have to find that. And it's going to come back to the Pythagorean theorem again. We will be using Pythagorean theorem quite a bit in a lot of these problems. But here for the two bases, we have 17 plus 37. And for the height, we're going to mark up our picture a little bit. So this dotted line here, I can slide it left and right. So if I slide it all the way over here to the right, I'm going to come here to this edge where if I draw a line straight down, I get a right triangle. Okay, so this is my height. To figure out what the height is, I first have to make sure that I'm using the correct length for the base. So the total length of this base down here was 37. Now if I go down straight down from this 17, this ends up giving me a rectangle, and then I end up with 17 down here at the very bottom. So to make sure that I'm using the right length for the base, I need to do 37 minus 17. So this is the base of the triangle. 37 minus 17, which is 20. So I have 20 down here. Now this allows me to use the Pythagorean theorem. And I have h squared plus 20 squared, and that's equal to 25 squared. H squared plus 400 is equal to 625. I take away the 400 on both sides, and then h squared is now equal to 225. And the square root of 225 is 15. Okay, so that is the height of this triangle. It's also the height of the trapezoid. So I plug in the 15 over here for h. 15 times 17 plus 37. 17 plus 37 is 54. 54 times 15 is 810. I divide that by 2. That gives me 405 for the trapezoid. Area is 405 inches squared for the trapezoid. Now for the semicircle, semicircle is pretty easy because we already know the diameter of it. The diameter is the height of the trapezoid. So for the semicircle, the radius is going to be half of 15, which is 7.5. So we have pi times 7.5 squared divided by 2. 7.5 times 7.5 is 56.25. 56.25 times pi is 176. 176.71 divided by 2. That's 88.35. So now my last piece is subtracting 88.35 from 405. This got kind of messy because there's so much stuff on here. So I have 405 minus 88.35. And then that gives me 316. We're just going to call it 316.65. So that is the total area of what's shaded over here on this trapezoid. So again, it's very similar to what we did with composite areas, except composite areas were finding the area of every shape, adding it together. And then with shaded regions, there's going to be some instances where we find specific shapes, area of specific shapes, and then we have to subtract those away because we don't want to include them in our final solution. So again, all of this is just with basic shapes. We will be using the Pythagorean theorem in some of these instances, like number 8 up here, for you to find this hypotenuse. I'm saying the hypotenuse because it's the hypotenuse of this triangle here. So for me to find the hypotenuse of this triangle, I have to use the Pythagorean theorem. 9 squared plus 21.6 squared equals this x squared. And then once I find this x, the x is used to find the area of the semicircle. Okay, so we're still combining multiple topics, multiple things that we've learned in the past to come up with the area, but it's all done with basic shapes. So that's going to be it for area of polygons and the rest of this unit. So in the next one, we will be taking a look at circles and how those apply to us in geometry.